In this video, we're going to learn how to simplify numbers with rational exponents. So I have 16 to the negative 2/5 power. So I'm going to show you two methods to go about simplifying this problem. So first, I'm going to start by changing negative 2.5 to a fraction. So I have 16 to the negative 5 halves. The first method involves looking at the prime factorization of 16, or see a different number raised to that power. So, for example, I can use the prime factorization of 16, which is 4 times 4, and then each 4 is 2 times 2. So 16 is the same thing as 2 to the 4th power. So I can replace 16 with 2 to the 4th. And then you can multiply their exponents. So 4 times negative 5 halves, which is 2 to the negative 10, which can be rewritten as 1 over 2 to the 10th. And 2 to the 10th power is 1024. So that's one way you could simplify that exponent. Another way you can simplify that number is when I'm seeing 16 to the negative 5 halves power, I could already move that to the denominator to begin with. So I can rewrite that as 1 over 16 to the 5 halves power, and then rewrite that into radical form. And whenever I'm simplifying numbers, I typically put the radical by itself, and then in parentheses, and then I raise it to the numerator power. It usually makes the math a lot easier because you're going to make your number smaller before it gets bigger. The square root of 16 is 4, which gives me 1 over 4 to the 5th. And 4 to the 5th power is 1024. I'm going to go over that process one more time with the bottom example. We have negative 32 to the 4/5 power. So the first method I could use is to break down negative 32, or even more importantly, 32. 32 is 4 times 8. 4 is 2 times 2. 8 is 2 times 4. And that 4 is 2 times 2. So I have 1, 2, 3, 4, 5 2's. So I can replace negative 32 with 2 to the 5th. But since this is an odd power, I can actually just incorporate that negative 2 into that 5th power. So I could rewrite this as negative 2 to the 5th raised to the 4/5. And then you can multiply those exponents. So 5 times 4/5, where the 5's cancel, and I'm left with negative 2 to the 4th. And negative 2 to the 4th power is 16. And the alternate method for this is to rewrite this into radical form. So I can write this as the 5th roots of negative 32, and then raise to the 4th power. Now the 5th root of negative 32, we know negative 32 is negative 2 to the 5th. So I can think of this as the 5th roots of negative 2 to the 5th, which leaves me with just negative 2 to the 4th power, which is 16. You'll often notice lots of common patterns between both methods, and it's usually just a preference as to which one you like to use more. So let's try this with a few more examples. So here we have 1000 to the 4/3 divided by 100 to the 3/2. So 1000 is also known as 10 to the 3rd, and 100 is also known as 10 squared. So I could replace 1000 with 10 to the 3rd power raised to the 4/3, and I can replace 100 with 10 squared raised to the 3/2 power. Multiplying these together, I get 10 to the 4th, because 3 times 4/3 is 4, divided by 10 to the 3rd, because 2 times 3/2 is 3. Now I'm dividing, so I can subtract the exponents. So 10 to the 4 minus 3, which is just 10 to the 1st, which simplifies to 10. Now let's say your power isn't in that fraction form, like you saw earlier. We just need to change it to a fraction. So 243 to the 6/5 power is the same as 243 to the 1.2. And then what I can do here is this time I'll use the radical form. I'll take the 5th roots of 243, and then I'll raise that to the 6th power. Now, 243 is 3 to the 5th. So I have the 5th roots of 3 to the 5th power, which leaves me with 3 to the 6th power. So if 243 was 3 to the 5th, 3 to the 6th is just 243 times 3, which should be 729. And the way I did that math is I did 3 times 200, which is 600, 3 times 40, which was 120, so I could leave me with 720, and then 3 times that 3, which is 9, so 729. Now next up I have 10,000 to the 0.75. Now let's say I didn't change that. That's when you can start to keep things in exponential form, and that can help you get to your answer. So if I realize that 10,000 is 10 to the 4th power, and the way I do that so quickly is I just count the zeros, and that is 10 to that power. So 2 zeros, 10 to the 2nd, 3 zeros, 10 to the 3rd, 4 zeros, 10 to the 4th. And I can replace 10,000 with 10 to the 4th power, and then I just have to find what is 4 times 0.75. Now you can definitely use a calculator to help you out. 4 times 0.75 is 3. And another way you could have calculated that as well, if you imagine this as 3 quarters, 3 quarters times 4 is 12 quarters, and that leaves you with $3. That's another way you could do that mental math. And you're left with 10 to the 3rd, which is 1,000, as we saw earlier. Lastly, we have 64th to the 2/3 times 64 to the 2/3. So I can actually combine these because they have a common base to be 64 to the 2/3 plus 2/3, which is 64 to the 4/3. Now 64 is known as 8 squared, 4 cubed, and 2 to the 6. Lots of ways to rewrite 64. So I'm going to write all those down real quick. So I could write this as 8 squared, 4 to the 3rd, or even 2 to the 6th. And all of those give me 64. But which one would be the best choice? Well, just looking at the denominator here, it's 3. So either 3 or 6 would be the best choice because both those numbers are divisible by 3. While 8 wouldn't be the best choice because you have 2 that wouldn't divide by 3 very well. So I'm going to replace 64 with 4 to the 3rd to the 4/3. And 3 times 4/3 is 4. So you're left with 4 to the 4th, which is 64 times 4, which is 256. And that is how you simplify numbers with rational exponents.